quick recap. We continue with the numericals. So we have C force vibration. We have the volume potential equation for it. For it. And solution has. Hello. Yes. The Gaussian differential equation has two parts to it: complementary function and particular integral. Okay, and we derived the equation for the magnification factor. Magnification factor in terms of zeta and r. The equation was 1 square 1 minus r square whole square plus 2 zeta r whole square, and phase angle is 2 zeta r upon 1 minus r square. We plotted the magnification factor versus frequency ratio and studied the characteristics of this curves, and also we plotted phase angle versus frequency ratio, and we studied the characteristic of that also. Okay, and we are working on numericals, and we started with this numerical. I don't know how many of you have finished this numerical. The solution for this was zeta is equal to.
Your screen share is off.
How about now?
No, sir.
The screen share is on.
Huh?
On has
On now?
Yes, sir.
it's on, sir.
It might be your internet connection problem. Just disconnect and join again. Those who are not able to see the screen. All rest of you are able to see, no? All right. So we have almost solved this example. So what I want to do is I have also posted the assignment. So what I want you to do is open up the quiz and fill the values in the quiz for the damping ratio and the steady state amplitude. I will just open the quiz, just a minute. All right, I have opened the quiz, just enter the answers and submit it at the end. Don't submit it now, because you have to solve other things also. So after, at the end, you can submit. All right, done. This was already done during the last lecture, damping ratio and fixed damp. Any questions so far about anything that has been covered? All right, can I go to the next example? All of you are able to see the screen, no? All of you are able to access the quiz? Hello.
Yes, sir.
Okay. All right. So let's start with the next question. A 65 kg electric motor is placed at the end of a 1.3 meter steel rod. Modulus of elasticity is 210 into 10 raised to 9 Newton per meter square. Cantilever beam of cross-sectional moment of inertia is 1.3, has a cross-sectional moment of inertia of 1.3 into 10 raised to 6 meter raised to 4. When the motor operates at 200 rpm, the phase difference between the operation of the motor and the response of the beam is 5 degrees. Assume viscous damping and estimate damping ratio of the beam. Okay. So rpm is 200. So omega twice pi n by 60. Modulus of elasticity is 210 to 10 raised to 9, and I is 1.3 into 10 raised to 6. So you have to find out the viscous damping and the damping ratio. All right. So let's first calculate the stiffness of the element. So how to calculate stiffness? that will be load per unit deflection. Okay. So W del will be, since it is a cantilever beam, it will be WL cube divided by 3 EI. Substitute here. So K becomes 3 EI divided by L cube. So find out K and then find out omega n, that is equal to square root of K by M. And therefore you get R, that is the omega by omega n, that is forcing frequency by natural frequency. Okay. Then use the equation of tan phi is equal to 2 zeta R upon 1 minus R square, and find out the value of zeta. And enter that in the quiz. The third question is the damping ratio. Are you doing it? Hello, are you done? If you are still solving it, please raise your hand in the chat box. All right, calculate and just enter the value in the quiz form. Part A, there are total 12 questions. One by one, we go. All right, moving on to the next question. Do you have any questions? Do you have any questions for this first question? Or second question in the quiz? All right, next question. Can I continue?
1 minute, sir.
All right, let's go to the next question. I'll just read the next question. Determine the transient and the steady state response of a mass shown in the figure. If an excitation force of F0 sine omega t, that is equal to 10 sine 15 t is acting on the mass. So 10 is the amplitude of force and 15 is the forcing reference. Okay, that is radians per second. The mass is initially at mean equilibrium position when the velocity is 0.1 meters per second. So at x0 dot is given, and so this is the system. So K1 and these two springs are in series, in parallel. So K is equal to twice of K1 basically. All right. And mass is given 580, C is equal to 4852 Newton second per meter. So let's solve this. So K equivalent, that is equal to K is equal to 2 times K1, that is 2.84 into 10 raised to 5 Newton per meter. Okay. And F is equal to F0 sine omega t. So it's 10 sine 15 t. So F0 is equal to 10 Newton, and omega, that is the forcing frequency, is 15 radians per second. Okay. And initial velocity x0 dot is 0.1 meters per second. Okay. Now in the question there are both the transient and the steady state response. Okay. So you have to solve for both the complementary function as well as the particular integral. Okay. So let's start with the complementary function. So zeta is equal to C divided by Cc, that is equal to C divided by 2m omega n. So find out zeta. Omega n is equal to square root of k by m. Find out omega n, and so what kind of system is this? Hello.
Yes, sir.
Yes, what kind of system is this? In terms of damping, type of damping.
Underdamped.
Underdamped. Okay. So how many, what is the damping ratio you get, zeta?
0.189.
Zeta is 0.19. So this is less than 1, so it is an underdamped system. And we have studied the underdamped system in detail. Zeta is 0.189, omega n is 22.12 radians per second. Okay. So we have studied this system in detail, and so the complementary function will be given as, can somebody tell me what is the equation for complementary function? Yes. So it is A e raised to minus zeta omega nt sine omega dt plus 5. So A is equal to A1 square plus A2 square. Square root of that, A1 is x0 is equal to 0 because motion starts from mean equilibrium position. A2 is given as x0 dot plus x0 omega n zeta divided by omega n into square root of 1 minus zeta square. So calculate this and find out A. Okay, and phase lag is tan inverse of A1 and A2. Okay, so this will give you the complementary function, okay, or the transient part. Okay, now let's look at the steady state response. So steady state response is xp is equal to steady state response. And that is given as what? Can somebody tell me what will be the steady state response?
X sine omega t minus 5.
X sine omega t minus 5, where 5 is the phase lag. Okay. And here you have to find out first the response, that is x. So that is x by x0 is equal to 1 upon square root of 1 minus r square whole square plus 2 zeta r whole square. So r is omega by omega n. You know omega n. You know zeta. So substitute and find out the magnification factor. Any questions? And so this will give you the value of x, because x0 is already known. What is x0? Yes, anybody? Hello.
0.1 meter per second.
Point. No, that is x0 dot. I am asking about x0.
0, sir.
Not if the x0 is 0, then this becomes infinity, no?
F0 by k.
Huh?
Minus 5.
Right. So how to find out what x0 will be given as?
F0 by k.
Okay, so that is what I wanted actually. So you know x0, so you can get x. All right, so x you will be able to find out, and so this will give you the equation as x of the particular integral. That is this x into sine omega t minus phi. What will be phi? How to calculate phi? X into x sine omega t minus phi. So you know forcing frequency. What is the forcing frequency? What is omega? Hello.
15.
15. And what is phi? How to calculate phase angle phi? What was the phase angle for the transient part? You have two phase angle. Now I am talking about phase angle for steady state part. But the response is composed of the complementary function, that is the transient part, and this is the steady state. All right. So for both of them, we have derived the equation for displacement, and now we are talking about phase angle. So what is the phase angle for transient part, and what is the phase angle for the particular integral? Can somebody tell me the equations and the values? Hello.
Sir, can you repeat?
The phase angle for both the transient part and the steady state part. How to calculate? Don't know? Nobody knows?
Sir, we can use the formula of tan pi, na? Tan pi equal to 2 zeta divided by 1 minus r square.
That is for which one? Tan phi is equal to
2 zeta
upon. So that is
One
for
minus R.
which steady part or the transient part? That is for the steady state part.
Sir, we have to calculate the x na for the question number 6 to MCQ, sir.
Yes, see, there will be two x. Here, this is for complementary function. This is for the particular integral. All right. So here, complementary function xc, I am using a constant as a e raised to. So xc is a e raised to minus zeta omega nt cos sine omega dt plus phi. All right. So that is the complementary function. The particular integral, this is given as x sine omega t plus phi. All right. So this phi you can calculate by this method. What about phi for the transient part? How to calculate that? Phi will be what?
Ratio of the complement of amplitude.
So can you tell me what the equation phi is equal to
Tan inverse of A1 by A2.
tan inverse of a1 by 8. All right. So what will be that value?
A1 will be 0 because initially it has rest
So-
at 0 position.
Okay. So what will be the phi value of phi?
0.
0. Okay. So phi will be 0. All right. So calculate that. And so calculate all these values and substitute in the quiz. And submit it. Any questions with anything which you have not followed? Anything different in the question from the derivations that you have done? Have you noticed anything different?
What, sir?
Anything different that you have noticed in this question from the derivation? What is the equation for the complementary function in the derivation?
So they are in the terms of sine instead of cos.
Okay. At least someone has noticed that. Alright. So because it is in terms of cos, alright, this becomes plus. Okay. In our derivation, it was in terms of cos, so this becomes minus. In terms of sine, it becomes plus. Alright. So that things you need to keep in mind. Alright. Submit all the answers. Fill in all the answers and submit the quiz.
So in fourth question, we have to write natural frequency, right? In fourth question, we have to write the natural frequency, right?
That you decide. When you submit the answer, see the force, the equation of the applied force is given in terms of sine. So I had to use the sine equation. Because force applied is F0, F is equal to F0 sine omega t. So that's why I use the sine equations. If it is in terms of cos, you have to use the cos equation. I have posted the third assignment today. So third assignment I have posted actually, I should have posted the second assignment first. But second assignment I have to prepare it. So third assignment I have posted it today so that you can start solving. Those who have submitted the quiz, please raise your hand in the chat box. Rest of you, lower your hand. Yes?
So for the assignment deadline आज का है तो वो extend हो सके सर for just 1 week.
Don't worry about it. वो तो मैंने just float किया था इसलिए वो by default आ जाता है वो आज का.
Okay.
I'll come back later. All right, so I hope most of you have submitted the quiz. So can I go to the next question?
Yes.
All right, so let's start with the next question. Using the given value, find out, determine the steady state amplitude of the block. Okay, so mass M of the block is given as 10 kgs, Mi of the disk is 0.1 kg meter square, radius is 0.1 meter, R is 0.1 meter. So it is a compound wheel. So that is inner one is R, outer one is 2R. Okay. Damping is coefficient is 640 Newton second per meter. The torque applied, amplitude of the torque is 100 Newton meter. Okay. Forcing rate 180 radians per second. Stiffness is 1.6 into 10⁵ Newton per meter. You have to find out the steady state amplitude of this block. Yeah. So let's first establish the governing differential equation. So let's first draw the free body diagram of the pulley. So forces on this will be Kx1 and let this be x2. So the velocity is 6x2, Cx2, and springs force is Kx2. Okay. So kinetic energy is half m into x2 square plus half I theta dot square. Okay. And x2 is equal to r theta. So x2 dot is r theta dot. Yeah. So kinetic energy becomes half m r square theta dot square plus half I theta dot square. Any questions you ask me immediately? Potential energy will be the potential energy in the spring half K x2 square. Stiffness of both the spring is same. Displacement is different, half K x1 square plus the damping energy force into dx. Okay. So again substitute x2 as r theta, x1 as 2r theta, and damping equation will be, it is damping is at radius r, so it is Cx2, correct? So this will be integral of Cx2. So instead of the integral variable dx, it will be dx2. Okay. So x2 is r theta. Okay. So dx, so substitute that in this equation. So you get integral c r square theta dot dt. Okay. And this I can rewrite as integral c r square theta dot d theta by dt into dt. So this becomes integral of c r square are a constant, theta dot square theta. All right. So the equations are like this. All right. This is the potential energy of first spring 1, and this is for spring 2, and this is for the damper. Okay. So these are all potential energies. Okay. And kinetic energy we have already derived. Okay. So according to the energy principle, kinetic energy plus potential energy is constant. So kinetic energy is m. We already derived this m r square theta dot square plus I theta dot square. Now I is already given. Substitute all the values. So mass is 10, r is 0.1, and I is also 0.1. Okay, and so this comes out to be half into 0.2 into theta dot square. Potential energy also substitute all the values, and this is the equation which we get. All right. Any questions so far? Can I continue? Is everybody clear how I got these equations?
Yes, sir.
Yes, sir.
So what is our equation? Kinetic energy plus potential energy is constant. Substitute all the values of all the values in the potential energy equation. So what is K? Yes, anybody? 1.6 into 10 raised to 5 Newton per meter. R is 0.1 meter. C is 640 Newton second per meter. So substitute all the values in this equation. So after I substitute, I get this equation. Right? So I simplify this equation. So this is my total potential energy. Right? Now I don't have to actually solve this equation. I will just compare this equation with our standard equations of kinetic energy. Alright. So our equation of kinetic energy is half I equivalent into theta dot square. Okay, so compare the coefficients of theta dot square. So I get I equivalent as 0.2 kg meters. Is that understood? Hello.
Yes, sir. Yeah.
Okay. So similarly, can you tell me what is the equation of potential energy? Potential energy is equal to, taking into account these two components. So let's the spring component, that is half K torsional equivalent into theta square. Alright, so that is the torsional potential energy due to torsional spring or equivalent torsional spring plus potential energy due to damping, that is C torsional equivalent into theta dot square dt. Alright. So again, now compare the coefficient. So can you tell me what is K torsional equivalent?
8,000.
8,000 units Newton meter per radian. Okay. No, radian. Degree.
Yes.
And what is the C torsional equivalent? Just compare the two equations. Yes, anybody?
6.4.
6.4 Newton meter second per radians. All right. So we got K torsional equivalent from by comparing the potential energy equation. So K torsional equivalent is 8,000 Newton meter per radian. And C torsional equivalent is 6.4 Newton meter second per radian. Okay. Any questions?
No, sir.
Okay. Now, what is the amplitude ratio? What for rotation? Or the magnification factor for rotation, that is, say theta by theta 0 will be equal to what? Hello. Yes, what will be the right hand side of the equation?
Under root 1 minus r square plus 2 zeta
1 minus r square whole square plus 2 zeta
2
r
zeta r whole square.
whole square. And r is omega by omega n, and omega n is square root of k torsional equivalent divided by I square. Okay. So we have already calculated all these things in the previous step. So substitute that and find out the value of r. What is the value of omega? It's forcing frequency. It is given in the question.
500 rpm.
500. Not 500 RPM. Where did you get 500 RPM? Hello, anybody else who can read the data? Hello.
Sir, it is correct.
What? 500 is correct? Huh? Do I need to go back to the first slide?
It is 500.
Huh? 500?
500 rpm. That is
Where
8.3 radians per second.
This is the data page. So here, where did you read 500? Huh? Can you tell it data and tell me now? You are saying the same data, na? Or something else?
I read the wrong thing.
So what is the forcing frequency?
One eighty.
180. K is 1.6 into 10 raised to 3. And what is omega n? What is K torsional equivalent?
8,000.
8,000. And what is I equivalent?
0.2.
Point. All right. So substitute that and find the value of R.
0.9.
0.9. Okay. And similarly, find zeta. So zeta is C torsional equivalent divided by C torsional critical. So that is something on the numerator into 2 into I equivalent into omega n. So find out zeta also. How much is zeta?
0.08.
0.08. All right. So we have got all the values now. So we have got zeta. So now here our equation is theta by theta 0 is equal to 1 upon square root of 1 minus r square whole square plus 2 zeta r whole square. Correct? So we need to find this theta. Okay. So for that we have all this, we have r, we have zeta, but we need theta 0. So what is theta 0? How can you find out theta 0? What is theta 0? Zero frequency amplitude in torsion. So how did you find out in translation? What was the equation? F0 by right. So here the torque is here it will be M0 by K torsional equivalent. So find out theta 0 and substitute in this equation and tell me the value of theta.
Sir, theta 0 is 0.0125.
0.0125,
113.
correct. 13. You have rounded it out. Correct answer is 0.0125.
The theta is 0.052.
0.0052.
052.
Units will be
Radians, sir.
radians. All right. Now what is asked in the question? Can you read the question?
Sir, it's asked steady state amplitude.
Of what?
Mass ka, sir. Mass.
Mass. So how to? So this is the steady state amplitude of what? This is the steady state amplitude of the compound wheel. Correct?
So
There is a compound wheel, one is smaller. Huh?
Sir, L equal to R theta के formula से जा सकते हैं सर मतलब R into theta.
Correct. So, so what will be the steady state amplitude of mass that is equal to, that will be equal to R into theta. Right? So that is R is 0.1 into theta, that is equal to 5.24 into 10 raised to minus 3 meters. So that is the steady state amplitude of the mass. All right. Any questions? Oh, guys, you need to have more questions. No questions are asked means you are not following anything. All right, can I go to the next one? A moment m0 sine omega t is now again here it is sine omega t is applied to the end of the bar of the figure. Determine the maximum value of moment such that the steady state amplitude of angular acceleration doesn't exceed 10 degrees. If omega is 500 rpm, k is 7000 Newton per meter, c is 650 Newton second per meter, L is 1.2 and the mass of the bar is 15 kg. Correct? Okay. So let's now calculate things one by one. Let's have this diagram. Just going to quickly draw this diagram over here. Let's just pivot over here. This is L by 4, this is L by 4, this is L by 2. And L is given as total length, that is 1.2 meter. Okay. and this is deflected, and this is spring 1, stiffness K, spring 2, stiffness 2K. Yeah, K is given as 7,000. That I'm not worried. So deflection, now this is getting deflected. Angular deflection is theta. Alright. So what is now one by one let's write the deflections. Deflection in spring 1 will be how much? Yes.
L by 4 theta.
L by 4 theta, correct? And deflection of spring 2 will be equal to
3L by 4 theta.
3L by 4. 3L by 4 theta. Okay. Displacement of the damper will be
L by 4 theta dot.
L by, no, displacement is L by 4 theta. Velocity of the damper will be L by 4 theta. Okay. So potential energy of spring will be what? Half K into L by 4 theta square plus half into 2K into 3L by 4 theta whole square. Okay. Kinetic energy will be, if this is the pivot O, it will be half IO theta dot square. Okay. And how to calculate IO? Inertia about O. Yes, anybody? Hello. What is I self? IO will be I self plus I parallel.
ML square by 12 plus ML square by 4.
Not ML by 4 whole square.
ML square by 6.
ML square by 60, correct, right? So IO will be ML square by 12 plus ML square by 60, that is 7 by 48 ML square. Okay, so now we have your potential energy, kinetic energy, and in addition to that, what is missing in here is the damping energy. That is also a potential energy. So that is F into dx. So that is equal to C x dot into dx, and x dot is the speed of damper. That is equal to by 4 theta dot, and x is L by 4 theta. Tx will be L by 4 d theta, or I can write it as d theta by dt into dt, or that is equal to L by 4 into theta dot dt. Okay. So substitute the dx in this equation and substitute the values of all the x dot in the equation, and I get the energy as C L by 4 square into theta dot square dt. All right. Is that okay? So x dot goes over here, dx goes over here. So L by 4 into L by 4, L by 4 square, theta dot into theta dot square into dt. Alright, so now we are going to solve it by a new approach. So let's sum out all the three energies. So let's write down the potential energy. And potential energy is equal to half K torsional equivalent into theta square. Kinetic energy is half I equivalent into theta dot square. Damping energy is C torsional equivalent to theta dot square dt. Alright, so these are the three equations. Theta square. Right. So K torsional equivalent is addition of these two terms. So that comes out to be 19 KL square by 60. Right. And substitute all the values and find out K torsion equivalent. Similarly, I equivalent or polar amide is 7 ml square by 48. On solving that, it comes out to 3.15 kg. And C torsional equivalent will be CL square by 16. And that comes out to be 58.5. Alright. So I have just substituted the values, whatever data is given in these equations. And I get this answer. Is that okay? Hello.
Yes, sir.
Okay. So now again we are going to do the same steps for steady state amplitude in torsion. Theta by theta 0 is equal to square root of 1 minus r square whole square plus 2 zeta r whole square. R is omega by omega n, and here somebody was reading data from this part. Omega n is K torsion equivalent divided by I equivalent. So find out R. Theta is pi by 180 into 10. All right, and what is asked in the question? What is the maximum value of the moment should be given so that the initial displacement is not more than 10 degrees. Okay, so this theta should not be greater than 10 degrees. Okay, the amplitude or angular acceleration should not be greater than 10 degrees. So this theta should not be greater than 10 degrees or 0.175 radians. So substitute here in this equation. Zeta will be C torsional equivalent divided by C torsional critical. So that is C torsional equivalent divided by C torsional critical. That is 2I equivalent into omega n. All right. So substitute the values and find out. And in this equation, substitute the value of theta. Theta is this value. Okay, substitute the value of R and zeta in this equation. Zeta is this value, and find out the value of theta 0. All right, so theta 0 comes out to be 0.06559. All right. So it is asked what is the initial torque to be given so that this deflection doesn't exceed this 10 degree. Okay. So मी तुम्हाला 2 मिनिटात लेक्चर सांगणार. All right. So K torsional equivalent, x0 is f0 by K, or K is equal to f0 by x0. Okay, so this is for the translation. So when I transform this equation to rotation, this K becomes K torsional equivalent, or torsion it becomes K torsional equivalent divided by m0, that is torque, divided by angular acceleration theta 0, angular deflection. All right. So K torsional equivalent you have already calculated, theta 0 you have already substitute and find out the value of m0. And that should be all for today. Any questions?
So 789.9.
Correct. Okay, quiz questions for part B will continue in the next lecture. All right, that's all for today. Thank you. Have you installed softwares?
So can you send any
No, sir.
Yes, can I send any?
videos that help us to install that? I mean, if anything extra required.
For installation?
Yeah, sir.
Okay, MATLAB is directly online installation. There is no. You can just directly you have to create an account on MATLAB. Go to MATLAB, create an account on MATLAB, and just go next, and that is for trial version.
So we only get 30 days to use it, sir.
Yes. So we are going to finish up our practicals within that time. Next 2 turns, we will be doing MATLAB.
Okay, sir.
Okay.
All right. Thank you.
Thank you, sir. Bye, sir.
All right. Bye.
Thanks, sir.